Okay, we're going to look at simplifying rational expressions. So a rational expression is an expression written in the form n of x divided by d of x, where n of x and d of x are polynomials. So n meaning numerator and d meaning denominator. All right, make sure you get the following examples on your paper. These are all types of rational expressions. 1 over x, x plus 2 over x minus 3, and finally x squared minus 5 over x squared minus 10x plus 25. Those are all types of rational expressions. Okay, we're going to simplify some expressions, and this should be a review from our unit on the laws of exponents. Okay, so we have 15b divided by 25b squared. And if I want, I could split this up and say it's the same as 15 divided by 25 and b divided by b squared. Well, I cannot divide 15 by 25 evenly. However, I can reduce that, and that reduces to 3 over 5. And with the b's, we can subtract. So I have 1 minus 2 is negative 1, or I could just reduce. The b on the top cancels, and I have 1 left on the bottom. To clean this up a little, 3 times 1 is 3. 5 times b is 5b. So there's my simplified answer. Okay, number 2, we can do the same idea, right? We have 36a squared b to the third divided by 18a squared b squared. So I could split this up as 36 divided by 18, a squared divided by a squared, and b to the third divided by b squared. Well, 36 divided by 18 is 2. A squared divided by a squared is 1. B to the third divided by b squared is b. So I'm left with 2 times 1 times b, or 2b. Simplifying rational expressions is similar to simplifying fractions. We're going to find and cancel common factors. The difference, this time, common factors may be a polynomial. So we're going to have to first factor out a GCF, or factor a trinomial, and then cancel our common factors. So in our next examples, again, we're simplifying each rational expression, but you notice this time we have binomials. The important thing here is you cannot, so do not do this on your paper. You cannot say, oh, these x's cancel out, and 2 divides into 12 6 times. You cannot do that. Okay? You cannot pick apart a polynomial. What we can do is we can factor and then cancel the factors that are exactly the same. So looking at the numerator, 6x plus 12, remember the first thing we always look for is a GCF. Well, I can factor a 6 out. If I divide both of them by 6, I'm left with x plus 2 divided by x plus 2. And we notice we have 2 of the same factors. So I can cancel x plus 2 and x plus 2. They divide to 1. And 6 times 1 is 6. So there's my answer. Similar idea number 4. You cannot just cancel the b's and the 2 and the 1. Okay? But we can factor first. So I'm going to factor GCF out in the numerator. My GCF is 2. 2 is the largest number that divides into 4, 4b, and negative 2. So if you factor 2 out, you're left with 2b minus 1 divided by 2b minus 1. And again, we have common factors. So 2b minus 1 divided by 2b minus 1 is 1. 2 times 1 is 2. All right, so those first 2 examples were pretty easy. Let's look at some more. All right, here's where it gets a little trickier. Number 5, we have 2x minus 12 divided by x squared minus 7x plus 6. So again, we cannot just start canceling like factors, but we can look to break down our polynomials and cancel factors that are exactly the same. So in the numerator, again, I look for a GCF, and here 2 is the largest number, divides into 2 and 12. So if I factor 2 out, I'm left with x minus 6. Now in the denominator, I have a trinomial. So I'm going to make my two sets of parentheses. First, factor x squared, so we have x and x. Remember, we were just doing this all last week. I look at the 6, so I want factors of positive 6 that add up to negative 7. So I know my signs will be the same. They'll both be minus signs. Factors of 6 that will give me a 7 are 6 and 1. Now I look to see if I have any like factors that I can cancel. And I do. I have x minus 6 and x minus 6. So then my answer will be what I'm left with. 2 divided by x minus 1. And you don't need the parentheses on the bottom or in the denominator if it's the only thing left. All right, let's try another. In number 6, we do not have any GCFs that we can factor out first. So looking in the numerator, I'm going to make my two sets of parentheses. Factor c squared. Now this time, I'm looking for factors of negative 6 that subtract to give me negative 1. So what factors of 6 have a difference of 1? Good. Negative 3, positive 2. We have divided by, again, let's make two sets of parentheses in the denominator. Factor c squared as c and c. Factors of 6 that add up to 5. Okay, so what factors of 6, same signs, that will add up to 5? Good. Plus 3, plus 2. All right, now we look to cancel. Okay, I have a c plus 2, c plus 2. I cannot cancel out my c minus 3 with my c plus 3 because they are different signs. My c's are positive, but my 3's are opposite signs. They do not cancel. So my answer is c minus 3 divided by c plus 3. That's it. All right, let's look at one more example. So again, we want to simplify. All right, I look to see if I have any GCFs first. And I notice in the numerator, I do. I have a GCF of 5. So if I factor a 5 out, I'm left with x minus 3. Okay, in the denominator, I do not have a GCF. I have a binomial that has an x squared. Now 9 is a perfect square, and 1's a perfect square. So even though it's written backwards, this is the difference of two squares. I'm not going to rewrite it. I'm going to keep it in this order. So take the square root of 9, you get 3 and 3. The minus sign tells me different signs, and square root of x squared is x and x. Okay. Well, looking at what I just factored, I notice I have no factors that are exactly the same. However, I look and see, okay, in the numerator, my x is positive and my 3 is negative. Then in the denominator, my second factor, my 3 is positive and my x is negative. So that means they're the same, they're just both opposite signs. So actually, we can divide these. So x minus 3 divided by 3 minus x is a negative 1. Okay, that reduces to negative 1. So if your factors are the same, except they are both opposite signs, you can cancel, but this time you're left with a negative 1. So my final answer here, well, 5 times negative 1 is negative 5. And in the denominator, I'm left with 3 plus x. Okay, and this concludes our lesson on simplifying rational expressions.